Hello. Welcome to the next section, Statistical Analysis for the Database Developer. This section will introduce you to the practice of statistical analysis. Now we move on to the first video, Data Analysis, where we will learn what is statistical analysis. Let's start by looking at what is known as data analysis. This is defined as a structured process undertaken to evaluate data using analytical and logical reasoning. One performs data analysis by taking the time to gather up all the data to be analysed, breaking that data into chunks or components, and then drawing a conclusion based upon what is seen or found within the data. Typically, this is done in an effort to determine that a data source is usable for meeting a declared project deliverable. To a data developer, data analysis involves inspecting the individual parts of a data source with an intention in mind. For example, suppose we have some transactional data collected from a bicycle manufacturing organisation that we want to potentially use for a sales performance reporting deliverable. Typical of these types of projects, let us say that we've been supplied data extracted from a database in CSV format. Now, using R commands, we can identify the fields or columns in the data, as well as view a summarization. We first use the read.csv to load our data file into an R data frame object. This is the location of our file. We then use the command col names to list the field or column names found within our file. Then we finally use the R command summary to instruct R to provide us with some statistics on our data. Running it, we get this result. Once we've established that our data includes product identifiers, a transactional quantity, a sales date, a return date, sales region information, and so on, we now want to do some analysis of the components found in the data. Perhaps we can start this effort by establishing the total number of records in our file, using the R command nrow. Then I list the unique part or product numbers present within our data using the R commands list and unique, as shown. We get the complete list of the. Further data analysis tasks would include examining each of the components found in the data. For example, what is the format of the date values found in the sales_date and return_date components fields? What is the range of dates within these fields? How many unique products and sales regions are included in our data file? To illustrate, let us use a few simple R commands to create a list of the years and the months found in our data. First, I read our data file into X. Then I convert X into a data frame object, then set the data frame to hold only the sales_date with this line of code. Then I use the R commands substr and regexpr to strip out just the year and month from the sales date field. Finally, I use sort and unique functions to list our years, then do the same to list our months. We can see that our data contains information only for the first quarter, months 1, 2, and 3 of the calendar year 2013. Now we have established our data's time series. There's still plenty of data analysis work that can be done, but the point is that we're performing analysis exercises aimed at establishing structure so that we can meet our original objective of sales performance reporting rather than any machine learning. With this in mind, let us suppose we want to examine what the transaction volumes are by month. To do that, we will use R to calculate these monthly totals. As we usually do, I first read the data, then initialize the counters. Then I add this code for loop and count. Once we have our monthly transaction totals calculated, using the preceding commands, we can then report those results. This can be done by creating a simple bar chart visualization. We can use the rbarplot function as shown. The command generates such a visualization. These described examples of data analysis tasks are just a few of the many steps that are typically completed when conducting data analysis work focused on a particular objective, such as delivering performance reports. To sum up, data analysis is about reviewing data to determine if it can be a valid source for creating a selected result, and, if so, how it can be used.